Hi, my name is Kevin Blower.
I'm Andy Espiritu.
I'm Scott Miller.
I'm Nolan Redpath, and for our ME229 design project, we are addressing the problem that people with limited lower body mobility or are confined to a wheelchair need a device to assist in reaching smooth and delicate items.
One of the activities we did at the Wilson Center allowed us to put ourselves in the shoes of somebody who would have a disability.
The existing extended reach devices out there on the market today, even though they're very affordable for users, they are somewhat crude in nature and can be very frustrating for somebody who is confined to a wheelchair to use.
Some of the problems we experienced with current reach or grabber tools was that it was unable to manipulate certain shapes and sizes at a distance. It was unable to manipulate smooth objects. We also noticed the grips were a little uncomfortable for most grabber tools.
So our scope for this project involves people confined to a wheelchair with regular upper body mobility, including grip strength and normal upper body strength. With our problem definition and scope in mind, our group set out to create a list of objectives that we wanted our grabber to be. We wanted it to be low cost, so as to be affordable to the user. We wanted it to be lightweight, so as not to strain the user while they're manipulating the objects. We also took into account buildability. We're constrained to the tools and materials in the Fab Lab. We also wanted it to manipulate a range of sizes and a range of shapes.
Since the user of our design is likely to be confined to a wheelchair, one of the primary tasks it must perform is to reach a higher cupboard to gain access to everyday items like cups and plates.
Initially, we were given two constraints by the professors. Our tool must be operated with only one hand, and it must be fabricated using only the materials and the tools available to us in the Fab Lab. We came up with some more constraints that had to do with safety. Our grabber must not have any sharp objects and must be made of non-toxic material. And in terms of lifting capability, it must be able to lift 5 pounds.
So our suggested solution consists of a claw, a shaft, and a handle. Now, for the claw, we chose to have moon-shaped claws and then elastic bands in between, so that way the user could manipulate different shapes of objects due to the fact that each cup has a different geometry and each bowl has a different geometry. Now, to lift plates, that may be in the top cupboard, we chose to have tips on each one of the claws, so that way it can grip on. And we chose to have a 2-foot shaft, so that way users could reach the top shelves of their cupboards in their homes. Because of this, we needed to add in a counterbalance on the forearm, so that way the user perceived less of a moment when lifting heavier objects. Now, we chose certain processes and certain building materials as our handle and claws consist of very strange shapes. So as far as building process go, we were limited to laser cutting and 3D printing. So for most of our parts, we decided to laser cut as it was more time efficient, and since the parts would be made out of wood instead of plastic, they ended up being a lot stronger as well. As for 3D printing, we 3D printed the parts that we can't physically build ourselves. So that was the little tips on the front of the claw, that was the trigger, that was the bands, the elastic bands we procured out of Ninja Flex, a material that we're using in the 3D printers app.